as she always has and probably forever will, that it is the best pump that's ever been created for managing diabetes. Mark is currently the Vice President of Marketing with Capillary Biomedical, which is a startup in Orange County. Used to be located, I believe, on the UC Irvine campus, and now they're in Lake Forest, a little closer to my hood. The research at Cap Biomedical shows that infusion set failures are common, with as many as 30% of infusion sets failing prior to the end of their third day. So, Mark, thank you for joining us this evening, being a little bit patient with us, as well as everyone else who's joined us here on Zoom. I can see that we're now live on Facebook, so if you're watching on Facebook, please go ahead, leave some comments. Sarah and I will be feeding them into the Zoom feed for Mark to answer. We will start with our typical disclaimer, so please everyone raise your right, your left hands, both hands in the air, both of your feet, whatever appendages you have, and claim that the Loop app is a do-it-yourself closed-loop algorithm and user interface. It's developed through the work of community volunteers, and while it may seem obvious, please consult with your healthcare professionals regarding your diabetes management and not just us here on the internet. It is important to understand that the Loop project is both highly experimental and also not approved for therapy. You are taking full responsibility for building and running the system, and you do so at your own risk. With that, I will toss it off to Mark, who has a beautiful screen share for us.
All right, I will add to that disclaimer that if I accidentally dispense anything that resembles medical advice, it was a mistake and you should not follow it. Thank you. Okay, so this is a great chance to talk to you guys about what we're up to at Capillary Bio and to talk about infusion sets and scar formation, which is what Joanne asked me to talk about. Joanne and I go back, God, to my Asante days, which is now going on, oh God, how long ago was that? It was 2002 or so a long time. And I've been in diabetes since '98 when I joined a little company called MiniMed. And a couple of days later, Miss America won with a blue pump, and things went nutty after that. So I've been in this space a while. I am fortunate I do not have diabetes, but I have a nephew who does on a pump. So this is the beginning of the speech. I'll tell you why we're working on infusion sets. CapBio is working on infusion sets because the JDRF suggested that would be a good thing for them to do with their talents. That was way before my time. And it's not a secret that infusion sets sometimes are very problematic. And so hopefully we're making a positive change there. A little about me. I was born in Iowa, but I live in LA now. I've been in med device for 33 years. In my early days, it was with respiratory products like CPAP and BiPAP. But a lot of time in diabetes. I think I got to MiniMed right before we launched the 508. And so I was there for 511 and 512 and the 712 and a good part of the early roadmap. We launched the early glucose sensors and the CareLink software and the QuickSet. Those were all things back in the day. The soft Serter, the SIL Serter, and the Sten Serter were all products that crossed my desk at one point or another. Went to Asante, which was M2 when I joined it. We made the snap pump, which is kind of a fun thing, but unfortunately never made it very far. And I've been with CapBio now since late 16, early 17. And we're working on what we call the StediSet infusion set. So I have about 75 patents and counting. A lot of those are take that last invention and add tail fins, but some of them are actually real inventions, maybe about 10 of them. So don't get too excited about that number. And my COVID-19 status is that I am isolating with my family pod of 6 people. I've been tested twice and I've been negative both times, and I got tested for antibodies and I was also negative. So I've been very lucky. So let's talk about infusion sets. And the sad thing is that while pumps and sensors have made great strides, infusion sets really haven't kept pace. And so this was the old days. There's the old polyfin. Some of you may be friends with that set. I think they're still around, but not in huge numbers. Big change came when they started making soft cannula sets, which was kind of in the mid-90s. But the thing about this set right here is it didn't have a way to disconnect, right? Once you put it on, you were stuck with it. unless you had a shower pack. Anyone remember these things? You had to stuff your pump in there so you could take a shower because you couldn't disconnect from your infusion set. And the same was true with the early glucose sensors. The first Medtronic sensor was wired. Wasn't wireless, which was crazy. But they fixed that when they introduced the quick release, and that was a big deal. That's one of the major innovations, and that was late 90s or so. That was a big thing. And we got inserters. Here's the old soft inserter. I think that's still around. Old ad. Look at it. It was a very dated ad I found. And modern inserters like this. This is the quick set inserter, the new version. The old one was that cute little igloo shaped thing. Those are pretty cool. And of course, they made ones that are a part of the package, which is nice. So insertion's been kind of a thing, but they haven't made a whole lot of other changes. And there has been a little bit of actually a de-evolution. I think that we can all probably agree that proprietary connections are not the best idea for a pump user. They're great for the pump company, but they're a pain in the rump for everybody else, including people trying to make new infusion sets, because now we need to have a different connector for every pump, which is one of the many banes of my existence. So when we looked at how to make a better infusion set, one of the best sources of data we found was this paper by the Stanford group. Lead author was Patel. And it was a summer camp study, but the pie chart on the right here is the sort of the meat and potatoes of what they found in terms of how do sets fail. And these were a mix of, I think, soft cannula sets. I think there were quick sets and steel needle sets. And they put them on kids and they let them run them until they failed. And they said, how did they fail and how long did they last? About 30% of them made it to 7 days. About, I think it was 80-ish% made it, maybe 75% made it to the end of 3 days. And these are all the reasons for failure. And they're kind of broad categories. Cannula failure is a pretty broad category, and I'll drill down into that a little bit. But pain's a big deal. The combination of accidentally pulled out and adhesive failure, I think those are two sides of the same coin in terms of the net result is your cannula is not in your body anymore. And then infection in the summer camp kids was higher than we normally see it in almost any other group. But those were all the reasons sets failed. So if you're going to make a better, longer lasting set, you need to try to put a hat on all those different causes. So trying to make more reliable cannulas, trying to deal with pain. If we could, we'd get rid of doorknobs and cats and big boxes and gravity and seat belts and all the things to grab onto infusion set tubing and rip it out. But that's a project for a different team. You can make better adhesive, and you can try to work on infection, but we haven't really focused on that. And certainly usability, these sets are not easy to use. You look at just the steps required to put in one of these early sets, and it's a lot of fidgeting for the end result. And they've made some improvements. I don't know if you've seen the Medtronic Mio Advanced that they just announced being available, but it's remarkable. It takes the number of steps and reduces it by about half. And so it's a much easier to install set. I'm not sure what other claims you can have with it, but it's at least a sign that you can make things more usable. And then particularly relevant to tonight's conversation is, well, you could try to cut down on how scars form, the scars that are produced post-infusion set wear at the site. And then generally speaking, waste reduction would be a pretty positive thing. So that's the big opportunity, and we focused on some of them. We're going to ignore others, but this gives me a chance to talk about cannula failure. And so looking at that piece of the pie, why do cannulas fail? And part of it is that the whole insertion process is error prone. There's always kinking, sometimes during use, sometimes during insertion. There's occlusion, and I separate that from kinking. Occlusion being that it stopped flowing, not because it was kinked, but because the tip was blocked. There's leakage, or some people call that tunneling, where the insulin leaks back along the outside of the cannula to the skin. But the big cause and the source of what I'm going to talk about tonight is Inflammation. So what is inflammation? What am I talking about when I say inflammation? Inflammation is the wound response that happens when you put a cannula in your body. So if you think about it, a cannula is a splinter that squirts out insulin. And that insulin has preservative in it. And the preservative itself is an irritant. The fact that there's a physical object in your subcutaneous tissue is something that causes the body to first try to seal it off. Let's encapsulate it. Let's throw a bunch of white blood cells at it to fight infection. And let's try to isolate that splinter so that it doesn't cause more damage and I don't get sicker. So your body reacts to an infusion set like it would to a toothpick. It says, hey, get that out of me. And meanwhile, it's forming a protective sheath around that item. So as that inflammation increases, the path that insulin has to go to get from the cannula into your bloodstream, and basically has to make it from the cannula through your subcutaneous tissue, which is mostly fat, right? It's fat with some capillaries spread through it. It needs to find a capillary. And that path gets more and more tortuous as the inflammation around the cannula increases. And at some point, you get to the spot where the insulin doesn't make it to a capillary and just sits there right by the cannula. And what's happening to that insulin, instead of working to lower your blood sugar, it's degrading and it's becoming not insulin. And that's when you say, hey, my set stopped working and my blood sugars are high. Well, that's if it's not an absolute physical blockage like an occlusion, that's the reason why. Basically, the insulin's in your body, but it's not making it into your bloodstream, and it soon won't be insulin because your body's pretty hot relative to what insulin likes, and so it starts to break down. And as you get more and more inflammation, of course, post use of that particular site, you've got more body material, more collagen and fibrin to have to be reabsorbed to avoid having a scar. So if we're trying to reduce inflammation so we can more reliably deliver insulin, a nice byproduct of that is that by reducing inflammation, we are reducing the core driver for scar formation, which is this collagen and fibrin response. So what does that look like? These are images where these are from a pig study. So no human gave us a tissue sample. And in looking at this, you see different slices. It's a cross section of the tissue at different time periods. So working from left to right, the image on the left, you see I think I can get my mouse to point. Let's see, yes, I can. This white thing is where the cannula was. The blue layer here is the skin. And what you see, this other areas that kind of looks like a marbled blue and white is your subcutaneous tissue. That's the fat. And you see the little blue stripes. Those are what we call fascia, the layers of membrane between the cells. And after the original insertion, there's not much going on. You see where the cannula was and you see the tissue. And you can see that maybe the layers are a little bit displaced by the cannula going in. 8 hours later, pretty much the same story. Not a lot of reaction has happened. But by the time we get to day 3, you see all the red forming on that slide. And these are not, of course, they're different samples from different animals. But on day 3, you start seeing where the fibrin and collagen have started to encapsulate the cannula. And at day 5, you see quite a bit of material surrounding it. And by the time we get out to like day 7, you're looking at a sheath that is pretty mighty around the cannula that's keeping insulin from making it to capillaries. And that progression of slowly forming essentially a sock-shaped or cylinder-shaped sheath of collagen and fibrin around the cannula is what we call inflammation, and that is why sets stop working. That's why they get flaky. So what can you do about that? Well, what causes inflammation is the first thing. And so one of the things that happens is insulin is not all that robust of a molecule. It's easily damaged or broken. And if it's broken, that has 2 problems. One, it's not as potent as it was because it's not going to turn into insulin you can use. And those aggregates can cause irritation unto themselves. So one thing that helps the insulin stay healthy, so to speak, stay in its hexamer form as it travels down the tubing and into your body, is keeping the preservative levels where they're supposed to be. And the challenge there is that it ends up that the preservative in insulin, which is the stuff you smell when you smell insulin, you're really not smelling insulin, you're smelling the preservative, the metacreosol and the phenolics that are in there. That stuff really would rather not be in solution. It would rather not be hanging out with the insulin. It would rather travel into the plastic that it's being pumped through. So the reservoir connector, the tubing, the hub, or the plastic bits on your infusion set, and finally the cannula. Some plastics in use are very much a happier place for that preservative to be than in the insulin. And so it evaporates into that tubing or absorbs into the tubing or other plastic. And then eventually it leaves the tubing on the other side. It actually goes out into the atmosphere. And as that preservative level drops, the insulin is more and more fragile because the preservative actually helps keep it intact. And it's one of these things that's kind of like the zombie apocalypse. Once you get a little bit of breakdown of the insulin, the broken insulin molecules now start attacking other insulin molecules in the mix. And so it's a cascade effect. It's like the zombie apocalypse. You know, the first guy gets bitten, and next thing you know, there's a whole horde of zombies chasing you. Same thing happens with insulin. Once you get a little bit of aggregate in the insulin, it starts to accelerate and you get more and more. The other thing that happens that breaks down insulin the same way is air. Little air bubbles, big air bubbles. Contact with air creates aggregates or can create aggregates. And again, it's like the zombie apocalypse. As soon as it starts getting worse and worse, right? And then, of course, temperature. Insulin is very temperature sensitive, and that's one of the things that we always fight, particularly in the summer, is keeping insulin at the right temperature to prevent it from breaking down. So all those things, not only do they decrease the amount of insulin that's coming out the end of your cannula, but the insulin that's coming out causes more irritation because it is the tissue doesn't like those molecules. Perversely, the converse of this is that the preservative in the insulin protects the insulin and makes the insulin happy, but it's an irritant unto itself. So in the ideal world, you'd have all the preservative in the insulin right up to the moment it left the cannula, and then it would be absorbed by some sort of preservative sponge sitting right there at the tip. That doesn't happen, but that would be the ideal situation. So there's a balance between how much preservative is used to make insulin and how much we try to keep in the insulin as it's delivered, versus how much we'd like to absorb before it goes into your body. And then lastly, one of the big causes for inflammation is just the mechanics of having a cannula in your tissue. So there's steel sets generally are very stiff and cause a lot of inflammation, which is why typically they're limited to 2 days of use. Teflon sets, which is every other set out there, are made of plastic and it's Teflon, are much more flexible than steel, but they're still pretty stiff and they cause issues. And then we've taken a different tact with our set, so we've gone with something softer, and we'll talk about that in a minute. In addition to just the stiffness of the cannula, the placement of the cannula mechanically relative to the skin surface. So we have 90-degree sets and we have angled sets. And while there aren't a lot of great studies on this, the typical folklore is that angled sets are better for a lot of reasons, but they're far more intimidating to insert. And it's believed that mechanically having that angled insertion is more of an isolation of the cannula as your skin surface moves and as you bump the infusion set hub and tape. It causes less motion underneath versus a 90-degree set where you're kind of pogo sticking straight up and down, and movement of that tip is often a big factor in inflammation. So what can we do knowing that that's what causes inflammation? We can do a few things. We can certainly try to deal with the insulin aggregates, right? So we can keep insulin at the right temperature. We can make sure we're using fresh insulin that hasn't expired. We can try to change the plastic bits out to make them preservative friendly, so it keeps the preservative in the insulin and protects the insulin better. And certainly there's been some clinical reporting from Medtronic on their what they call their extended wear set that's still in development, where that was one approach they took. We're taking a very similar approach. We found some tubing that is preservative friendly and keeps the preservative at levels which keeps the insulin happy. The other thing you could do is you could try to remove the aggregates from the insulin while it's still in the tube or in the reservoir. And Medtronic has shared information at both the ATTD that was in Madrid this spring, and then at the virtual ADA, where one of their designs has a filter in their connecting cap that is, in theory, takes aggregates that are found in the reservoir and removes them prior to delivery. We found that we also managed to remove aggregates before delivery, a different mechanism, which I'm not at liberty to share how it works, but I know that it does because we looked at what's in the reservoir and we looked at what comes out the tip, and we have about half the amount of aggregate coming out the tip as was found in the reservoir, which is interesting. The other thing we can do to help is spread the preservative out over a greater tissue area. So preservative is one of these things we kind of have to have based on the fact that it's keeping insulin happy. So once we get it into your body, if we spread that out over a bigger area, the amount of preservative per volume of tissue will be lower. And so that's one approach we've taken. I don't believe Medtronic has done anything like that. And then in terms of mechanical agitation, you can make the cannula more flexible and you can put it in at an angle. And we did both of those things. So this is a picture of, at least it's a drawing of what our cannula looks like. It's a close-up. It's actually the same diameter as any of the Teflon cannulas. The difference being we put 3 side ports. These are the 3 green circles to the right, in addition to the open tip on the left. And it's made of such a flexible material that it would actually be a terrible cannula if we hadn't put that wire reinforcing coil inside of it. So it's a really tiny little coil, but it's sufficient like a dryer hose. It doesn't collapse when you bend it. So it makes the cannula kink-proof. And those side ports work to spread the insulin out over a bigger area. And this picture is actually from a high-resolution micro CT scan, so a little tiny CAT scan of the excised tissue that had the cannula in it, and that we had delivered right before we took the sample from the pig. We delivered some radio-marked insulin, so that you can see where did the insulin go. So the big blue cloud is generally where the dilute insulin is. The darker or brighter green, there's 3 blops. Those are showing where the higher concentrations of insulin are coming out from the 3 side ports. And then you can kind of see faintly in the background this spirally looking slinky thing that's kind of bent from vertical to horizontal as we move from right to left. That's the coil inside the cannula. So that's what you're looking at. And this example is particularly interesting because in this one case, the tip had been occluded by pressing up against muscle, we believe. And so we were getting all the delivery out the side ports and none from the tip. So it demonstrates that we not only have sort of this lozenge or cylinder-shaped plume of insulin coming out, but that we have redundant paths, which are helpful when you get occlusions. And if you measure using the CAT scan software, we were able to measure the surface area of that plume, and we found it to be roughly twice the surface area of, same volume of insulin was delivered, but the surface area was improved. And if you think about sort of efficiency of packaging things, a sphere is the most compact way to package a given volume of anything. And a cylinder shape is not as efficient. And what we've done is changed from having a sphere of insulin delivered at the tip to a much more of a hot dog shape that is delivered along the cannula and spreads it out. And we get more surface area for the same volume as a result. The other thing we did is, because we're flexible and angled, we were able to cut down on inflammation. And so we did a study on pigs where we looked at the same familiar images on the right of here's a cannula that's been in for 6 days. The top one is the standard, I think it was a Teflon cannula, maybe a Quickset or a Mio. The bottom one is our cannula and at an angle. Using this is histology, so you're making microscope slides and you're using tools in the microscope to measure the thickness of that layer. And taking samples across 14 days, we showed that the thickness of the inflammation layer with our cannula is about half the thickness that we find with a traditional Teflon cannula. Part of that we believe is the flexibility, and part of that we believe is the angle. So 2 factors there, but you can see this is pretty clear that on both of these images, there's a pretty good barrier being formed around the cannula in both cases. Ours is about half the thickness, which we hope will show that in the long run, we can get insulin into the bloodstream more effectively or more consistently over time. And that's the whole point, is trying to make sure that the delivery of the insulin is not the question. You have enough variables going on to try to control glucose. We don't want the delivery of the insulin to be part of that anymore. And it certainly is today. So we took that cannula, and this is the only real rah-rah commercial slide I'll put up here for us. We took it, we packaged it into an infusion set that has its own integrated inserter. So we end up with a kink-proof multi-port soft cannula designed to improve reliability. And our goal is to demonstrate clinically that this thing can last for 7 days. Angled placement and softness definitely are helping reduce the inflammation. The multi-port design we talked about, it ends up that the engineers did a great job on the inserter design, and it comes preloaded. It is very, very simple to use. So much like the one I plugged for Medtronic earlier, this inserter is about the same in terms of complexity. You peel off the tape, you stick it on your body, you squeeze the 2 buttons. It deploys the cannula, pulls the needle back out, and tucks it away, sharp safe, so you never even saw it, and you don't have to worry about throwing the inserter into a sharps container because it's not sharp anymore. One of the things we found out that we weren't expecting is that it actually doesn't hurt very much. And it was remarkable. The first couple of times I inserted one of these, I wasn't sure it worked. I was like, did that work? And sure enough, the cannula was in me. And hopefully we've actually changed our plans where instead of just hoping that it was the same as other sets, we're actually now asking questions in the clinical trials to see if we can demonstrate that it is better with respect to pain. And that would be cool for new users. Might be good for kids. But I don't know if there's anyone who wants more pain from an infusion set. So I'm saying that's probably a win. And if we can pull off once a week replacement, that is a much smaller pile of garbage you're throwing away every week, and hopefully a much better user experience in terms of the amount of time you spend on your plumbing, because you got plenty of other stuff to do. All right, that's the end of my commercial. But here's the big question. Will that set actually reduce scars? Well, I don't know, right? The theory says it should, because if we have less inflammation to begin with, we have less stuff to have to be reabsorbed afterwards. But I have 0 clinical data to support that. And it's not the primary focus of our initial trials. Those are focused on just demonstrating that it's safe and effective. So I am not making any promises or claims to that end. But I will point out on the bright side that we designed it to be used one-handed, both from an insertion and connection standpoint, which is not the case for every infusion set, which if that plays out, it gives you more places you could reach with one hand versus 2, which gives you more real estate to work with. And if you're only changing it once a week, the rate at which we're using up real estate should be reduced. So there is hope. Even if I don't stop scars, I might be able to slow down the progression of you running out of places to put infusion sets, if that's something that bugs you. Certainly from interviews, it's something that bugs more than a couple people. I think that's the end of my spiel. I went through that pretty quick, so I'm sure there's some questions.
Hey, Mark, this is Joanne.
Sure. Hey.
Thank you so much for it. I caught most of this.
Thank you very much, Mark.
Okay.
Cassidy,
Always interesting to hear from you guys. And I feel like I'm having myself a little bit of a flashback because Priscilla and I came in to give feedback and we were in there surprisingly together. We'll feed in some questions to you coming from the Facebook feed. If it's okay with everybody else, I wrote down 3 questions of my own here on the side. If we could start with that, the last cap slide. What does multi-port design actually mean?
So multi-port is back to this. It's the 3 side ports plus the end. Mm-hmm. So we're putting insulin out over the distance between the 2 far ends of that is about 6 millimeters. So it's spreading the insulin out, hopefully, over a broader area under your skin. That's what we mean by multi-port.
Cool.
Is that clear?
Thank you for clarifying.
Sure.
One of the first things that popped into my head as you were showing the tissue response as increased days on the cannula was going by was, as our automatic insulin delivery systems are being further developed, and obviously this is a looped group, we're all very familiar with having aid systems do a lot of work for us. Do you think, or would you recommend that future algorithms auto increase basal rates through successive days of cannula wear? Well,
I think that a good algorithm would do that sort of automatically if it's finding, if whatever algorithm is controlling the loop, if it needs more insulin to keep glucose in range, it's by default it should be able to deliver that. And so clearly just the early commercial systems that shut off basal for a low had nothing to do with that. But as we get to now, they're in sort of the 2nd gen commercial systems from Medtronic and Tandem, and you guys are on the loop, so you guys are on basically a very advanced system. That algorithm ought to be smart enough to increase the dose as resistance increases, and so I think there's a positive to that, in that you might be able to eke out a few more days of use from a set, even if we didn't change anything. The negative is if there's a big stepwise change from day 7 to the next time you put in a new set on day 8, and it's going from the image on the right back to one on the left. If that algorithm has held on to any sort of, hey, this is the current, call it a insulin sensitivity on day 7, might not be the same on day 8 if you've changed the set between them. So there's a fairly good argument to make that some of these more adaptive systems need to really watch out for this. And I'm not sure, where any of the developments for the various either DIY or commercial systems are with respect to that. But it's been discussed that certainly a lot of the algorithm guys think that if we could have more consistent performance from day 0 to day 7, that it makes that less of a challenge for the loop to deal with. And that's my hope. So I think that we get to sort of a win-win if we have good loops and we have good infusion sets. And until then, I think there's a caveat that changing a set does do a stepwise change to your predictability and possibly to sort of a net effective insulin sensitivity if you're stretching a current set past 3 days. That would be my word of caution, right? That's a good question.
I see an interesting question from Marianne in...
Let's see. Craig on Facebook Live has just asked if this is being designed so that Omnipod can use it also.
That's a great question. We've talked to several different patch pump companies, and it's clear that this technology would be a great fit. At least I think it's a great fit. And we hope to work with at least one or more of them. But I will say that there's no formal deal today, and I don't blame any of the current or would-be patch companies from not signing up yet, because we really haven't shown that there's a there. We are just now about 2/3 of the way through our first human trials in Australia, and we got stalled twice by COVID-19. They had a flare up and they shut it all down, and then they opened it back up, and now they just like a week and a half ago shut us down again because we're in Melbourne, or Melbourne as they say, and they're having it's a hotspot, so they're trying to minimize the amount of clinical resources being used for anything but dealing with COVID. But our results are promising, but they're not yet published, and so I think in the fall I will have some pretty good material to take to a bunch of different people and try to talk them into planning for putting our cannula technology into their patch, which would be really awesome. Because if you think about it from, I don't know if you follow Insulet from a business perspective, but one of the things that's been a common theme for them for 10 years or so is profitability. And I know that doesn't matter so much to an insulin pump user, but certainly Insulet would love it if the same hardware could last a couple more days, right? Because they're literally having to replace all the disposable stuff, and it's expensive. If they can eke a couple more days out of it, from their perspective, it gets a lot better. Certainly from a user perspective, being able to go longer on a pod and not have to change them as often is the same dynamic as you get from being able to go longer on an infusion set and not being able to change it as often.
So Mark,
you can plan better.
So Mark, does that mean that
Craig said, wow, he's an Australian living in the US. So I feel like he's excited to hear that response, that your clinical trials are happening in Australia.
Yeah, and we did that because we got a little high-sided with the FDA on the amount of biocompatibility testing that they wanted us to do on our cannula. Surprised us, and that's one of those things that just takes time. And it's our cannula is something that's been in use in other medical devices for 15 years, but they made the argument, well, yeah, but they didn't use it with insulin, so show us the results. And we're like, okay, we can do that. It's just going to tack on 6 months, and we don't want to wait 6 months, so let's see if we can do a clinical trial somewhere else where the FDA is not involved. It was Australia. All right. I heard a very faint question during that. What was it, Joanne? Was that you?
Yeah, it's me. Can you guys hear me?
I can now.
Okay, great. Hi, Mark. Thank you so much. So there's a question earlier that
you can hear Joanne. That's good. I can't hear Joanne.
Hi, Cassidy. You did a great job. From Marianne, who's in Brisbane, by the way. Does the insert under pressure with a trigger-like mechanism like other okay, let me keep trying. Does the inserter insert like other inserters, or is it a slower insertion, more like the G5 sensor inserters?
I don't know what a G5 sensor inserter does. I do know that our inserter is a little bit different. So most inserters are sort of like a pogo stick, right? It's a cocked spring that's a linear spring, and it's all coiled up, and it inserts is like a major forward motion, and then it stops, right? It's just the spring opens from a compressed state to a stretched state. We have more of a rotational mechanism. So we actually, because we insert and then retract the stylet, leaving just the cannula in place, it's a different force profile and a different speed profile. So we are moving at we are slowing down as we insert, and we actually pause. So when we hit the bottom, instead of moving at the highest speed, which is how most current inserters work, they're accelerating all the way till they bottom out, and then there's a hard thump. We are slowing down until we get it in place. And when we get it in place, we actually come to a brief stop. and there's a slight pause, and then we pull the cannula out. So it's a different velocity profile. And I suspect that combined with the fact that we tape down first and then insert through the tape, and that helps stabilize the skin so that you don't get a dimple as you're inserting. Instead, we're holding the skin against the base of the infusion set and then inserting through the skin. I think those two combined are what is causing the marked difference in pain or perception of pain during insertion.
When I first saw what you guys were doing, I remember sitting in the car with my husband before we went in, and I said, I really don't think this cannula stuff's all that important. And we started to almost have an argument when he said, you don't understand. You have the mechanism of the pump, which is supposed to work. It's just mechanical. Then you have the insulin, which is the variable. Then you have the food and your algorithm. And then you have the absorption of getting the stuff in. And that's what you guys are doing, and it's different. So I just really personally want to thank you for thinking outside of the box. You did that with Snap Pump. You're doing it here. I just sit here and say, I just told you I want to fall on this thing and try it. So a couple of questions. What is the ideal length of cannula for a less lean adult versus a very lean child? Are there different cannula lengths that you expect to have?
Well, the math there is you want to be past the skin, which there's pretty good data out there that says you need to be at least 3.5 to 4 millimeters deep. And then you want to be, after that, it's all fair game until you start to hit muscle or bone. And so if you look at the human species, we have a fair amount of places where we have a pretty good layer between skin and muscle or bone, particularly given our average calorie intake as a nation. So humans have a lot of places where you have a good layer of fat to put a cannula. We have gone with, and you know, the recipe here is that anywhere from sort of 5 or 6 all the way up to 9 can all work from a vertical standpoint. Going in at an angle, all you're doing is your tip is going to be at the same depth, but you're buying yourself a lot more length between the surface and where that tip is in terms of not vertical, but along the route of the cannula. We went at an angle because it helps us spread those side ports out. And so even though our side port, the top one, is 6 millimeters from the tip, because we're at about a 30-degree angle, it's still plenty deep in below the skin. And what you don't want to be doing is delivering into the skin, because the absorption in the skin is far more variable and can be really, really fast or not at all. So you want to be in the sub-Q layer. So any lengths that get you there without poking muscle, to me, are good lengths. And so the current sets that are 6 to 9-ish in terms of 90-degree sets, and the angled sets that are sort of 13 to 17-ish, those all are pretty good answers for putting the tip somewhere in that space. We went angled because, of course, it gives us more room to spread those side ports out.
Okay, so this is longer than the 6 to 9 millimeter.
Well, our tip is nominally about 7 millimeters deep.
Okay.
If you think about the geometry of how we're positioned, we're going in at an angle, so the tip is about 7 millimeters deep, which is kind of like a silhouette or I don't know what they call them, the Verisoft. They've got so many names for these things, but all the angled sets are roughly that same geometry, about 7 millimeters deep, plus or minus a millimeter. And the long versus the short adds about another millimeter to that, right? Because of the angle. Okay. And 90-degree sets are somewhere between 6 and 9. I think there was one that might have been 10, but I don't think it's around anymore. And you couldn't go much lower than 5 because now you're closing in on the skin, and you don't want to be in the skin. Okay,
another question that you may or may not have tested in this. In your studies, have you found the infusion sites get problematic or messed up with temp basal suspends from the advanced systems?
That's a great question. We haven't seen it. We've only got, we have data from, it's 13 users, so that's 26 1-week wear periods. And for the most part, they're on a blend of Medtronic 670s, or what's the one before the 670, 630, I think. I don't know their nomenclature. Or they're on tandem pumps, and I think they only have basal IQ at this point in Australia, at least in that clinic. And so we get a fair number of, you can see on the traces, the pump traces, because we downloaded them all. You see a lot of pump suspends, but we don't see any issues in terms of occlusion or degradation when the pumps resume. We haven't really seen that. It's a question we talk about a lot, particularly with our clinical advisors, and it's certainly something we're going to have to look for as we go into more of the trials that are aimed at getting to FDA clearance. But it hasn't thus far been an issue, and certainly we've experienced a fair number of pumps suspending for lows.
Okay, so thank you. The questions that I see coming up a lot is, so are you talking to Omnipod? So is this going to be in a pod? Is this a possibility? Are you able to say anything about that?
Well, I kind of touched on this a minute ago or 5 minutes ago, but we would love to be in a pod. We've talked to those guys. There's no formal business deal that's going to put us in a pod right now, and I don't blame them for not putting that deal together, because we are just now at the point where we actually have human data to talk about. And so it's reasonable and rational for us to say, hey, it doesn't make much sense to get into a serious conversation until we can show that we actually have the goods. And we're right about the point where those conversations need to happen. And so, this gets into sort of the business plan for us. And I think I have one simple slide that says where we are, and I'll pull that up. It's at the end. Oh, I went too far. There we go. So where are we? Design's stable, right? And we got good usability. We've done 13 users. That gives us 26 1-week wear periods, and we're very encouraged by the results. They weren't perfect, but they were really good. We just now have started what we call a PK/PD study, which if you look at the label, the big sheet of tissue paper that comes with your insulin, somewhere in that piece of paper, there's a graph that shows the pharmacokinetics and pharmacodynamics of the insulin relative to, I don't know how they did the study, but those studies are only done sort of in a snapshot on one day of use. And so the study we are starting right now down in Escondido is to run our set and do a clamp study on day 1, day 3, day 5, and day 7, and do that again with a Teflon infusion set, and try to get a good understanding of how does insulin absorption change as a function of time with these two sets. And it's a tough study to run. NIH funded it, and they were very generous in their funding, because everybody wants to know the answer to that. Even if we didn't have a set, all the scientists and loop builders would like to know that data on regular sets. And so this study gets that, and it gets it for our set. And that's happening at the AMCR down in Escondido. If anyone wants to do a clamp study, they're recruiting. It's not a fun study. You have to show up and sit there all day, maybe even stay overnight. But you want to be a cool kid and get involved, go ahead. Get down there.
Did they put you up at a spa?
Not a spa. I think it's more or less their clinic, which has a bunker, would be the way I would describe it. Maybe better than a bunker, but not a spa.
So it's interesting. SoCal Loopers, which is now pretty much worldwide, is about 800 and almost 850 loopers. And if at any point it makes some sense that there should be a voice going to any of the manufacturers saying, put this in, particularly to Omnipod, when Loop was able to run with Omnipod, the number of loopers using Omnipod jumped. It jumped by thousands. People were waiting to be able to use Omnipod. So we're strong users in their market. I don't have numbers, but I know we created quite a bit. So if you need a writing campaign, I'm sure we could do that.
Well, I will keep that in mind. The conversations we've had are not antagonistic. They're pretty positive. Like they get that if this works, it would be worth having a really good discussion. And there's other people working on patches, and they get it. And certainly the major pump manufacturers understand what's going on and aren't strangers to us. Medtronic has a pretty big program on their own, and they got CE marking on what they call an extended wear set. It does some of the things we do, but not all of them. That's still a great move forward, and they may or may not think they need us, but they're still talking to us, and we're on friendly terms with everybody. So our hope is to distribute this through all the major pump and pod manufacturers, because there's no reason to have a separate distribution company just doing infusion sets. That's a lot of work there's a lot of duplication, right? So we would sell it to them as like an original equipment manufacturer, and they would then in turn do all the insurance processing and the retail end of it.
Absolutely remarkable. Yes, because we want the best that will work the best for us. We did a presentation on the psychosocial issues of looping, and it's really anyone with tech and diabetes, and we want it to work the best it can. So if your device does more and gives us more, that's the one we want. So at least I'm speaking for myself and maybe the group, but yes, go forth, go do it. I'm excited to hear that you're still edging it forward despite COVID.
Yeah, it's kind of interesting. We didn't know what was going to happen with the COVID thing, and everybody, we were working from home primarily, and we had, our office is there in just south of Irvine, and ends up that we've become a more effective, probably better organized because of sort of the discipline forced by having to schedule when you're using the lab, because we have 2 lab areas, and we make sure that we are being very good at social distancing and not exposing each other. We had a couple employees that had a scare. So one of them, their live-in significant other had COVID, and so they had to stay home for 2 weeks. But generally speaking, all the modern tools like Zoom meetings and teleconferencing, we've actually gotten better at getting stuff done. It's kind of weird.
It's a whole new world order.
Yeah,
we're reaching more people, and some of the comments I'm seeing, I don't think people understood as much of what you've told them today. And I've been excited since day one. I'm so glad and appreciative of what you've done. I didn't get a chance to do the intro, but you should also know Mark is, an interesting man. He did go-karts, high speed, little things. I don't know what you call them.
Soapbox derby was one of my hobbies for a while.
Okay, you're a drummer. You make your own beer and spirits. You have turtles, tortoises. You have dogs.
We lost one. We're down to 1 tortoise. The other one ran away. I don't know how it happened.
Wow.
We think he teleported.
Wow.
There's no way out of the yard, and yet he's gone. So we don't know what happened.
And the other thing you need to know is he's quite an artist. He designs LED displays, clocks, laser cut sculpture. It's truly a Renaissance man. So you want to follow Mark and kind of keep track of him, because he does amazingly interesting things. I just want to thank you. Thank you for the time. Thank you for sharing this information. Thank you for opening up our world to what you're doing and how you're helping us. Really appreciate it.
You're welcome. This is, without your guys' input, we wouldn't know half the stuff we know in terms of what we're trying to do. And so the local people who have come through have been hugely beneficial and helped us really get a sort of a grip on what are we trying to do, what problem we're really trying to solve here.
I don't know if you remember one of the focus groups, we were talking about the inserter, and you had been doing it in the lab and there were mostly guys there, and you noticed the women were holding on to the inserter in a different way. It's because we have longer fingernails. What I noticed at that point was you listened to the users. It's the first time I had seen that, and it's just really excellent. So thank you. You have a couple of people who are on Snap Pump on this call, and you should also know Dale is still using the Snap Pump. So I will fill you in offline on that, but thank you so much for what you do.
Well, you know what? It's a good use of creative energy to try to solve problems that matter to people. And again, a word of disclaimer: if I gave any medical advice, I apologize. Ignore it. And this device is not for sale. We are a couple years out, right? I think in 2022 for launching. But keep your ears open. If you're in SoCal, we will probably be doing some of our clinical pivotal and pilot studies in the U.S.
Well, if you let me know, I'll put it out to the group. You know I'm ready. Just bring it to my house. We'll just test here. We're good.
If you stop by, if there's a chance to get in the same building at some point, you could stop by and probably fall on one accidentally, and we wouldn't talk about it. But.
It can happen. Thank you very much. You have a very.
Oh, you're welcome.
Any
other questions? Are there any questions online that aren't answered? Because
no. If they do come up, I will send them over to you, and people can connect. I think this was way out of the normal of what we're talking about, but I think it's so significant because if getting the insulin into our body isn't working well, it doesn't matter how we do our settings.
It's the plumbing. A really smart pump can be screwed up by a dumb infusion set. So.
I will quote you on that.
Yeah.
Alrighty. Thank you so much. Everybody have a good evening.
Thank you guys. It was fun.